Hello and welcome to the video where I derive an extremely useful equation for solving these non-stick equations without having to go through all the steps over and over again. So we're going to have two objects coming at each other at some speed, and then they go off at some angle. We don't know if the angles are positive or negative, but we need to find the x and y direction of each of their deflections. So in the x direction, we have MA VAX plus MB VBX equals MA VAX prime plus MB VBX prime. So take this triangle here. We're going to call this the A triangle. So this is theta A, and this is VA prime. So this is VA prime cosine of theta A, and this is VA prime sine of theta A. These will stay the same. I'll rearrange those in a second. Equals MA VAX prime is this way, so that's VA prime cosine of theta A. And the same thing goes for VBX prime. So, MB times VB prime cosine of theta B. So, what we do is we rearrange, and then to find, because we're looking for B, so make sure you make B your unknown. Make B your unknown, because A is going to be all values that you know. So what you're going to have here is VB prime cosine of theta B equals, and I'm just rearranging really quick because I don't have much time in this video, equals MA VAX plus MB VBX minus MA VA prime cosine of theta A over MB. And since we're going to be solving for VB here, we're going to divide cosine of theta B over here. So that's one of our equations. Now we do the same thing with the y direction. MA VAY plus MB VBY. I don't know if you've noticed, but I'm trying to get my camera to stay focused. And I think it's going a little better now. I remember when it just wouldn't cooperate at all, and it'd just be blurry the entire video. Anyways, so all that is the same equals that is the same. So this is going to be VA prime sine of theta A, because up here that's in this direction, plus that, and then VB prime sine of theta B. And you might be thinking, well, why isn't that negative? And the reason why is because we don't know that they deflect in opposite directions. And if we do, then that angle will tell us that. If we take the negative of that, we'll actually get the opposite of what we are supposed to get. So I hope that made a little sense. So VB prime sine of theta B equals, and I'm just rearranging really quick, equals MA VAY plus MB VBY minus MA VA prime sine theta A over MB. And again, we're going to divide by sine to get sine of theta B. This is kind of boring, but now we get into the good stuff, in my opinion. Anyways. So we're going to set, since these are both VB, we can set these two equations equal to each other. So we have, I should start higher. That'll work. MA VAX plus MB VBX minus MA VA prime cosine of theta A over MB cosine of theta B equals MA VAX plus MB VBX, running out of paper, minus MA VA prime sine of theta A. Right there is sine of theta A. And you don't need to write any of this down. I'm just writing it down so you know where it came from and it makes sense to you. Sine of theta B. So cosine of theta b and sine of theta b are what we're solving for, because we want to know this angle right now. So we're going to multiply sine over here. So we're going to get sine theta b over cosine theta b, which is what we want. So to get those by themselves, we need to divide that over here and multiply mb up here. So we're multiplying mb up into the numerator. So you have ma vax, blah, 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 blah. All that stuff that's right here stays there. Under here, that divides in there, so we have mb times ma va. Oh, that's what ma va, sorry. Ma vax, blah, 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 blah. But bottom line is these mb's cancel. And I'm going to move on to, I'm actually going to flip the page over, because I write too large or something like that. So simplifying all that, and this is the big one, tan theta b equals ma va minus va prime sine of theta a plus mb vby. And remember that prime is after it starts moving. So say b isn't moving to begin with, all these vb's, that's 0. But VB prime would not be 0 because that's after it starts moving. Over MA VAX minus VA prime cosine of theta A plus MB VBX. Now these don't cancel because you have another term here. It's just algebra. So this is the big equation that you want to know. Just write on your test, derived from conservation of momentum. Like you just put a star and say equation derived from, and he'll know that I made it basically because I walked up to him and told him. But I have checked that this works. I don't think I'll do a stick one. The test is Thursday. It's not worth it. I'm too tired. But, I hope this helps you. I know it's not the easiest thing in the world to plug in, but it's easier than working it out, I think. So, oh, by the way, once you have your theta, you're going to need to actually plug it back in one of these two equations to find the velocity if need be. So, that's all I got. Thanks for watching.